Hi, good morning everyone. This is Ritika Mahajan, MedTech Fellow, CIBioD, and I welcome you all to this short-term attachment program 2022. I am pleased to welcome our speaker, Dr. Sukhdeep Singh, PI, Dr. Varinder Garg, co-PI, Dr. Harish and Dr. Sakshi, coordinators from various institutes, and all the participants who have joined the session. So today's session will throw light on the design and development of HWR system using AI in healthcare. Before starting this session, I would like to play an introductory video of CIBioD. So please have a look. Hello. Hi, good morning all. As you all know, this session is about design and development of handwriting recognition system using AI in healthcare. Hope this session will be of greater use to all the participants. Having said that,
Let me introduce myself first. I am Ashita Joshi, MedTech Fellow at ICMR CIBioD. And with that, let me introduce our guest speaker, Dr. Sukhdeep Singh, who is currently working as Assistant Professor in the Department of Computer Science and Applications at DM College, Moga. He was a postdoc researcher with Boise State University in USA and holds his PhD in pattern recognition in computer science from Punjab University, from where he has pursued his MCA as well. His research interest lies in many fields, including pattern recognition, machine learning in the area of handwriting recognition, and image processing. We are pleased to have him with us for this session. So everyone, please welcome Dr. Sukhdeep Singh. Sir, the platform is all yours now.
Good morning, everyone. First of all, I would like to say special thanks to CIBioD team of PGI who given an opportunity to me to speak on the topic of development of HWR system in healthcare. So let me share my screen. Is it audible?
Yes, sir.
Yes, sir.
So the topic of today's discussion is design and development of HWR system using AI in healthcare. Here HWR means handwriting recognition and AI means artificial intelligence. AI has become a buzzword in these days. So as far as AI is concerned, it is about designing an intelligent system with artificial intelligence. Means we are training a machine to behave like humans, and the intelligence that machine is having is artificial. That machine can learn with experience, and that machine can be trained with special features and many other things. So a system with intelligence is expected to behave in the best possible manner as the human being behaves. Knowingly, unknowingly, we deal with AI in many manners. So artificial intelligence is a subdomain of computer science, where pattern recognition, natural language processing, machine learning, aggregation, classification, and many other things are performed under the umbrella of artificial intelligence. So many times we get confused with machine learning and artificial intelligence. And sometimes these words are also used alternatively, but that is the wrong thing. As far as machine learning is concerned, it is subdomain or a narrow term of artificial intelligence. So it is a subfield of artificial intelligence. Artificial intelligence is a subdomain of computer science, and in artificial intelligence, further machine intelligence is subdomain of artificial intelligence. Machine learning is a kind of artificial intelligence, but when we are concerned with a special type of artificial intelligence that learns with experience, that is called machine learning. So we can say it is very important to note that all machine learning techniques are classified as artificial intelligence ones. So we can say that it is subset of artificial intelligence, and artificial intelligence is superset of machine learning. So when a machine learns with experience using AI, that is machine learning. Machine learning has a variety of real life applications. One of the applications is face recognition. It is used for attendance systems and biometrics and many other systems. It is also used in gesture recognition. there is no need of intermediator or translator when we have to understand gesture recognition. Special deep learning systems are used for gesture recognition. And for the training of pilots and many other virtual reality systems, machine learning is used because where it is very tedious job to provide the training on live environment. In that case, a virtual reality environment can be created, and even in that case, machine learning is used. Then speech recognition, again, there is no need of translator when we are using machine learning for speech recognition. For example, someone is speaking in Hindi language or Punjabi language, and that particular language could be understood by our system, and our system can further translate that language to required language. Machine learning is also used in robotics, and even on many websites or many companies like Amazon, Netflix, and social apps are using machine learning for advertisement and to handle large amount of data, that is called big data. And for medical field, machine learning is used for image processing to enhance the quality or to extract the relevant features from the images. And then there is subfield of machine learning, that is pattern recognition. And in pattern recognition, there is subfield handwriting recognition. That's the topic of today's discussion. So here the question arises, what is pattern? A pattern is an object or a set of measurement objects describing a physical object. Like all we having Aadhaar card and we are having Aadhaar number. And our Aadhaar card details or Aadhaar number can be extracted with our biometrics, and our fingerprints are also a pattern, and we are writing something on paper or digital device, and when that particular text is understood by the computer, that is also using pattern. And our eye scanning or face scanning, our hand scanning, all things are pattern. So means something is stored in a machine and an object is matched with that stored data. That is a pattern. So pattern recognition uses various algorithms, statistical models, or system to recognize the unknown patterns. So pattern recognition works in two phases. First one is learning, that is also called training. And second one is testing or detection. Like when we learn to drive the car, it takes a lot of time. But with the passage of time, that thing becomes natural. In the same way, whenever we are using different statistical models for pattern recognition, we need to provide a number of features for learning or a large amount of data for learning. But when that machine is trained efficiently and sufficiently, our machine can recognize future patterns also. So as I have already discussed, handwriting recognition is a subfield of pattern recognition. So whenever handwritten text written on wall, any paper, digital surface can be like pen, tablet, or our laptop screen or our mobile screen. When that is understood by the computer, that is called handwriting recognition. Handwriting recognition must not be confused with OCR, optical character recognition. In case of OCR, we will use printed text, and in case of handwriting recognition, we will use handwritten text. It will have free flowing. It will not have a specific aspect ratio, where on the other hand side, OCR will have a fixed type of font, and there will be no overlapping of characters, and there will be less noise. But on the other hand side, handwriting recognition have certain more challenges for recognition by a machine. The handwriting recognition can be categorized into two types: online handwriting recognition and offline handwriting recognition. In case of online handwriting recognition, we will directly write on a digital surface. That can be pen tablet surface, our laptop screen, our mobile, or any other digital device. It will also capture the uh, pressure of the pen, velocity, and various other things while we are writing on the digital surface. And on the other hand side, offline handwriting is about first the text is written on the paper, then that particular text will be scanned by the computer. After that, there is digitization process, then binarization process, and then that text could be understood by the computer. That is offline handwriting recognition. Here we can see when we are writing offline, in that case, various things like pressure on a particular point on the screen or on the paper, that is not considered. But when it is written in online mode, it has certain more advantage for handwriting recognition. So when we have to develop a system for handwriting recognition in healthcare, there will be certain challenges that we have to face. First challenge will be non-availability of benchmark dataset for handwriting. Because for doctors' handwriting recognition, we will rarely or very less chances are there that we will find any benchmark dataset for doctors' handwriting recognition. So we have to first create our own dataset according to the OPD cards of that particular hospital, and then there are various further pre-processing steps to benchmark our data set. Then second challenge is symbol order variation of characters. Someone can write a symbol first, second, and other one can write that particular symbol in the last. So this challenge is also in handwriting recognition. But in case of OCR, this challenge is not there because machines start to print from the top left corner and it goes for typing to the bottom right corner. But in case of handwritten text, there could be symbol order variation. This thing also need to be considered. Then in stroke order variation, same character can be formed with different stroke order variation. What is stroke? Stroke means pen down to pen up trajectory. Trajectory means handwriting trajectory. So even that can be possible in handwriting recognition. Other problem is that unfamiliarity of writers for writing on a digital surface. Even educated persons don't know how to write on digital surface. So first we have to train our expert as well as beginner and moderate writer to write on the digital surface. After that, the other challenge that we will come across for development of a handwriting recognition system is limited available literature. Either this is interdisciplinary field of medical science and computer science, but the available literature to work in this direction is very limited. Then different writing styles is other challenge for handwriting recognition. Different writers can write the same thing in different handwriting. And even small characters can be written with scattered or segmented strokes for writing. And similar nature of character, that is called isomorphic shape of characters. And then some writer write in cursive nature and some writer write in isolated nature, and some writers use mixed cursive handwriting for writing on the digital surface. So these are certain challenges that we will have to analyze or we have to face for the development of a handwriting recognition system. Although there are various changes or various challenges for the development of a handwriting recognition system, but the scope of automated handwriting recognition is very vast. Handwriting recognition can be used for the electronic form filling, and it can also be used for writing applications in our own handwriting, in our own native script, and the computer can understand. There can be situation where some person knows their native script but don't know how to write or how to use native script for writing on the digital surface. So in that case, handwriting recognition tool can be used. Other advantage of handwriting recognition is that we can use handwriting recognition or handwriting recognizer at a computing device. There is no need of keyboard. If the computer is that much proficient to understand the handwritten text, then in education, handwriting recognition has the advantage that while a mathematician or other teacher is writing on the board, his or her handwriting is directly converted to the typed text, and that text can be used as notices for students. We can write SMSs in our mother tongue, and it has also advantage to use handwriting recognition tools in biometrics and digitization of palm leaf manuscript and census data collection. So there are n number of areas where handwriting recognition can be used. In the same way, the handwriting recognition can be used for the design and development of a HWR system using AI in healthcare. So what are the various phases that we have to use for the development of a HWR system using AI in healthcare? First one will be data collection, then pre-processing, then feature extraction, after that segmentation, recognition, and post-processing. We will discuss all these steps in detail. The first step for the development of HWR system using AI in healthcare is data collection. There are two ways for using or performing data collection tasks. First thing is that we will have available benchmark data set. We can use or divide that data set into train and test data set. If there is non-availability of benchmark data set for the development of HWR system in healthcare, we will have to first collect data from different writers. When we are collecting data from different writers, in that case, we can either use pen tablet, or we can also use different digital writing boards where the writer can see as well as write their text. But if we are using pen tablet, in that case, we have to see the handwritten text on the screen and we are writing on a different device. Other option is that we will have different OPD cards of different departments. We have to scan that data, and we can use different types of DPI resolution for scanning the data. Normally we can use 600 DPI for resolution. After that, we have to separate words and images from our collected data, because it is not sure that the doctor will just use handwriting or just use text for writing on the OPD card. We can also draw some images on the OPD card. So we have to separate that data. And once our data has been collected, after we have that, we have to perform the pre-processing task. Pre-processing means we are processing our data to be used by the HWR system. So there can be data that can be left skewed or right skewed. There can be a lot of noise in our data. There can be many unwanted things present in our data. So there are a number of pre-processing steps we have to perform to use our collected data for to be used in HWR system. So these are like binarization. Binarization means we are converting our original image to the binarized image, where there will be only black and white image, and all the image data will be converted to 0, 1. And there can be slant correction if our image is left skewed or right skewed. Then skeletonization means instead of using thick lines of handwritten text, we are converting all different size text, which where thickness can be varied to thinned image. Like here we can see that the image number 3 is the thinned image. Then there can be certain sharp edges or unwanted trajectory in our handwritten text that also need to be removed for correction of the image. So the baseline detection where the text is written, contrast, stretching, and removing the selected connected components means dividing into different parts of the collected data components. So there are certain pre-processing steps that we have to use our collected or scanned data for the development of HWR system. Once we have collected our data and we have pre-processed our data, the third step is feature extraction task. Feature extraction task means we are finding certain properties of different types of characters of handwritten trajectory so that one character can be distinguished from the other character. So feature can be statistical as well as structural feature. Statistical features are like aspect ratio, horizontal line, vertical line, slanting line, and mean of the various strokes, many other statistical features that we deal in statistical data. And a structural feature like whether there is any sharp edge, whether there is any curve in our stroke or character, whether there is a top to bottom line drawing, or whether there is any dot present on the top of a character or at the bottom of a character. These all are structure features. If we are using online features of our handwritten trajectory, in that case, we can also consider velocity and pressure of writing on the digital surface. So feature extraction basically means, for example, I'm writing A and B characters. How A is different from B structurally as well as statistically is called extraction of features. Basically, it is finding various properties of character that will distinguish one type of character to another type of character. Once we have performed first three steps, means data collection, pre-processing, and feature extraction, segmentation is done. Segmentation is performed. Segmentation can also be done after pre-processing of data. Segmentation means dividing the collected data into smaller units. Like we are having different paragraphs in our document. Then in that case, the data will be divided into different paragraphs. But in case of HWR system in healthcare, there are very less chances someone will write in paragraph form. So once the OPD cards are scanned or directly written on the digital surface, then segmentation will be done at line level, word level, as well as character level. So there are many deep learning models where there is no need to segment our data into character level. We can directly use LSTM or CNNs for word level segmentation. And so at this step, we will divide our data into smaller units. I will also show some practical application of this. Once we have collected data and pre-processed data, feature extraction has been done and segmentation task has been performed. The next task is recognition task, means handwriting recognition task. As we can see in this diagram, machine learning deals with big data, data understanding, regression, clustering, NLP, and many other techniques. But in case of handwriting recognition, we deal with three main things: clustering, classification, and deep learning. Clustering is a unsupervised learning technique. It is needed or required when we have collected our data. After that, we have to divide our data into classes. So when we don't know in advance what are the number of classes, in that case classification cannot be used. So we have to perform clustering at that step. Once clustering has been done, then after clustering, the different clusters are labeled as class labels. And these classes are used for training the recognizer. If we are using classification techniques, which will be used after the training of the model, in that case, we may use different recognition techniques. And hidden Markov models are mostly used in speech recognition and handwriting recognition. In case of hidden Markov models, we will deal with statistical or probabilistic data. We will divide our handwritten or handwriting trajectory into different components, and these components will be treated as states. So what is the probability of moving from one state to another state, or what is the probability of omitting a particular character from all the states is used in hidden Markov model, which is also called HMM. We can also use polynomial as well as linear SVM for classification. But these days, the feature extraction step is also eliminated with the help of deep learning. How it is possible? In case of deep learning, we just have to give the valid data to the machine. The deep learning models will automatically extract certain features from the given data, and then the prediction can be done on the basis of that. In case of deep learning, three models are most commonly used for handwriting recognition. First one is LSTM. Second one is BLSTM, and third one is CNN. If we are using with image data, in that case we can use convolutional neural network, CNN. if we are having online data or we are directly writing on the screen and we are having sequence data, in that case LSTM and BLSTM can be used because these fit well for sequence data. So there are different techniques that can be used for recognition tasks. Once we have performed first all steps, then the step is post-processing. Post-processing means our recognizer has identified certain words from the handwritten trajectory, and on the identification there can be possibility that these words are not part of any domain. So this can be further accurated or further rectified using a post-processing task. So basically, in case of post-processing, we will use dictionaries or grammar or language models for performing the spell checking and or finding the relevant words. For example, if we have to just identify the names of medicines, in that case, we will have a lexicon of medicine names. So whatever is recognized by the R recognizer, the recognized word will be further post-processed from the available dictionary and the closest match is given as an output. So this is what is done in post-processing step. So these are various steps that we have to perform to develop an HWR system in healthcare. So basically, we can develop three types of systems for handwriting in healthcare. First one is hard copy OPD cards. Second one is writing on the digital surface. And third one is air handwriting recognition. I think we have already discussed first two ones, because in case of offline handwriting recognition, we will use hard copy OPD cards, and if we are directly writing on the digital surface, whatever his doctor has to write, he has to directly write on the digital surface, and that will automatically recognized by the system and it will be converted to the typed form. So first option and second option are covered into offline and online handwriting recognition. And third one is air handwriting recognition. This one is new one. So I will discuss air handwriting recognition in detail. So whenever we are developing any HWR system in AI, so there are different modules. The first module will input an image, and once the image has been inputted, after that, that image will be converted to binary image. Then whatever the regions are present or regions of R and drugs are extracted from that image, then we will filter the unnecessary regions from the scanned document. After that, we will divide our collected data or scanned data into textual as well as non-textual data. And after that, we will work on the textual data or handwritten text data for further processing. Then segmentation and classification modules will be used, and after that post-processing module will be used. So these are different modules that we have to develop for developing any HWR system in healthcare. So as far as air handwriting recognition is concerned, in case of air handwriting, we will not use any surface for writing. So we will directly write in three-dimensional space. People can wear like armbands or leap motion or kinetic can be used for writing in the air. For example, if any doctor is operating in the operation theater and he has to perform a certain surgery, and in that case it is very tedious job if he has to write on the paper or any digital surface. So if there is any idea or anything he has to write, he will directly write or directly wave his finger or hand in the air, and the movement of his hand will be captured by different cameras. And once the movement has been captured by the different cameras, there will be a video, and from the video different frames of the video will be extracted. And once different frames are extracted, after that the frames will act as an single page document, and from that particular we can use our existing handwriting recognition system. So it is only about how to detect the uh, motion of hand in three-dimensional space, because there will be need of special cameras, and how to mark the starting and ending of text. These all things will be covered into air handwriting. So these things should be considered. So one of the advantage of using air handwriting in medical science is doctor can take his own note regarding patient during operations. So whatever is in his or her mind, he can directly write or directly note without using cumbersome equipment. So there is a difference between air writing and online handwriting recognition. In case of online handwriting, there is pen down and pen up information available. But in case of air handwriting recognition, it is very difficult task to identify where to start a particular word or from where to end a particular word. So this is also a tedious job to detect. So there are various problems that will be faced for development of an air handwriting recognition system. One is start and end point. Other is variability of human skin tone. So how to identify particular skin tone for writing in the air, and multicolor skin segmentation. There are a number of things. So let us look a small application that I have tried to develop for this handwriting recognition system. So here I have scanned one OPD card of PGI. You can see that in this OPD card there are various things present, like these circles, OCR text, handwritten text, and one this diagram over type is present. So the first task, that is data collection. I have just scanned one OPD card. So here we have seen this OPD card. After that, I have developed this code where image will be first read from this folder, then that image will be converted to black and white, and there is also need of rotation of the image, so then that will be rotated. After that I will perform segmentation. So let me run this code. Yes. So here you can identify that whatever relevant or necessary data that I need to identify is present in OPD card is marked by yellow color rectangles or squares. Once that data is identified, then it is further segmented into words and characters. You can say here, let me zoom it. Here you can see that all characters and words are identified. So wherever there is something relevant to be recognized by the machine is identified. So our data has been collected, then it is converted, image is binarized, then after that it is segmented into different components. So this was PGI card OPD, PGI OPD card. So let me take one more OPD card. Like this is the DMC OPD card. So let me scan this. My system is little slow. So again, you can see that different trajectories of OPD car are identified. So once we have identified these different trajectories, we have to classify which is our textual data, which is non-textual data. So for that, I have developed this module. So this is the image repository. Once we have scanned our OPD card and segmentation or word level segmentation is done, it is, so these are different components of OPD card. Once it is done, after that, the text versus non-text module will divide data like this. So these are our text images, and these words further need to be segmented, and these are our non-text images. So once we have scanned our OPD card or we have directly written on the screen, after that we have to perform segmentation, and after segmentation we have to classify it into textual as well as non-textual data, and then we will use certain machine learning techniques like LSTM or CNN for further recognition. So this was all about the development of HWR system in healthcare. Thank you. Is there any query, ma'am?
Am I audible?
Yes, yes, ma'am.
Yeah, students, do you have any query regarding the topic? Okay. Okay, thank you so much, sir, for sharing your valuable time with us.
Okay, ma'am. Thank you. Thanks to you as well.
Yeah. So students, basically we have created your groups according to the preference you have selected. So the groups I will share with you via email. Okay, so we will notify you via email regarding the groups which we have formed according to the preferences you have shared in the problem statement. So thank you so much, all of you. Thank you so much, sir.
Thank you.